Hello everyone, my name is Hariharan Doraisamy and my metric number is MA20080. I'm from Group 2 and today we will be presenting about free fall experiment. So for the introduction, free fall is a special type of motion in which the only force acting upon an object is gravity. Free fall occurs when an object is allowed to fall under the influence of gravity without any initial velocity or air resistance. By carefully analyzing the motion of the falling object, we can gain valuable insights into the principles governing free fall and the constant acceleration experienced by objects near the Earth's surface. Objects which are said to be undergoing free fall are not encountering a significant force or air resistance. They are falling under the sole influence of gravity. Under such conditions, all objects will fall within the same rate of acceleration regardless of their mass and height. This means that under free fall, all objects have the same constant acceleration, which in the metric system is 9.81 meter per second square at sea level, directed towards the center of Earth. So for the objective, the first objective is to investigate kinematics of a free fall from rest, and the second one is to investigate acceleration of gravity. Thank you. That's all from me.
Assalamualaikum and hello everyone. My name is Muhammad Firdaus bin Muhammad Noor. My student ID is MA20108. I will explain about the experiment setup. First is the apparatus. Number one, we have a ball pen to hold and release the binder clip in different heights. Number two is binder clip as an object to drop. Number three, we have a ruler to measure the head of binder clip we release and to measure the position of the binder clip. Number four is sellotape to attach the ruler and ball pen after measure the head. Number five is a tablet with acoustic stopwatch. For the procedure, we have the ruler is based along the edge of the vertical wall by using the sellotape starting with 0 mm at the floor. Second is the binder clip is hung as an object at the tip of the ball pen and is set at the falling distance, which is 100 mm from the floor to the under of the binder clip. Number three, the falling distance is recorded. Number four, the acoustic stopwatch on the tablet is prepared. Number five, the tablet is placed slightly away from the point of impact as the object hits the floor. Number six, the clip ball is pressed and the binder clip is allowed to fall freely in the air. Number seven, the falling time is recorded. Number eight, the process is repeated to obtain the average falling time. In this experiment, we take a 3 measure reading. And number nine, the same steps are repeated for different height. Next is how I will show you how to set up the apparatus for this experiment.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syahmin bin Nordin and we move to the result and calculation. Okay, for the result, we collect the data for the variables of height between 100 mm to 400 mm, and then we collect the data for the time fall between 3 value and get the average value for the time, and then we calculate for the velocity for the each of the height taken. And then for the sample calculation for the average, we take 1.122 plus 1.122 plus 1.122 and then divide by 3. to get the average value for the first height, which is 100 millimeter. And then to get the velocity, we take the first height 100 millimeter divide by 1.122 average of fall time to get the 0.0891 meter per second.
So now moving on to discussion. Discussion number 1. Why there are some differences between experimental gravity acceleration with accepted gravity acceleration 9.81 ms square. There are some differences between experimental gravity acceleration with accepted gravity acceleration. Firstly, it is due to the distance, which is too short. Secondly, it is because of the accuracy in taking the time. And finally, the plotting accuracy also contributes to the differences between experimental gravity acceleration and accepted gravity acceleration. Second discussion. From the table in table 1, what is the relationship between fall height and average of velocity? If the fall height increases, the average velocity also increases. Next, the third discussion. In your opinion, what will happen to acceleration if we change the steel ball diameter 15 mm to 20 mm? Explain why. If we change the diameter steel ball, it will not be affected by acceleration, while acceleration is still constant, because acceleration is independent of mass in the formula, which the gravity is fixed, g equals to 9.81 ms square. The size did not affect the acceleration of the steel ball, but mass of the steel ball can affect the acceleration due to formula W equals mg, where W equals weight, m equals mass, and g equals to gravitational. If mass of the steel ball increases, the acceleration also will increases. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syafiq Fatih bin Bani. My number matric is MA20095. Okay, I want to present about the plot a graph between velocity and falling time average t. Okay, for this one, I made a handwritten, and for this one, I made using a Excel. Okay, for the gradient, I use a handwritten and not at Excel. For the graph, velocity is in a y-axis, and the falling time average at x-axis. Okay. Okay, this for gradient or acceleration. 0.27 minus 0.1 divided by 1.27 minus 1.112 equal to 1.13 meter per second square. Okay, that's all.
Good day, everyone. My name is Gunaraj Gajendran, and my matrix number is MA20052. And today I'm going to discuss about the conclusion of our experiment. So basically, free fall is the motion of a body, which the only force acting on the object is the weight of the body itself. The rate at which an object's velocity changes over time is called acceleration. According to Newton's second law, an object's acceleration is determined by the total of all the forces acting on it. With this, gravitational force is the sole force that's acting on an object falling freely. Height and velocity are proportionate. The experiment demonstrates that velocity rises with the height. The experimental value of g differs from the recognized value of 9.81 meter per square due to a number of flaws. including an inaccurately measured distance, inaccurate timekeeping during the experiment, and inaccurate plotting of the graph. Thank you. That's all from us.